What is going on, everybody, and welcome to part 5 of the generative Python transformers videos. In this video, we are going to be hopefully building the trainer and actually training this model. Now, we are training this model on nowhere near enough data at the moment. We only have 76,000 basically samples, which is just not enough. We should have millions, hundreds of millions, or billions. So yeah, this is just not enough, but I am curious just to see, like, could we get anywhere with this little amount of data? But also, to be clear, I will, after this video, once we see that everything is working and training, I am not going to be using this data set moving forward. I do have 100 gigs of Python data. I'm going to build the file this exact same way. So yeah, so just keep that in mind. But for now, we're going to work on this small one just to see if it works. We are also going to train GPT-2 from scratch. The other option is to fine-tune it. So the P in GPT is pre-trained. The idea here being that, OpenAI can train the GPT-2 model on their, like, whatever it is it like 10,000 GPUs? They have some absurd number of GPUs. It might even be 100,000. All I know in my head is it's absurd. And at least behind me, I do have a pretty absurd machine, not going to lie. Not quite 10,000 GPUs, but it's got 4 of the A180 gig GPUs in it. So we will be able to do quite a bit of training on there, but it certainly doesn't compare to 10,000. I'm guessing they're V100s. Anyway, so we're going to train this one from scratch, only because I've played with GPT-2, just like the pre-trained models, and they're not like, it's impressive for like natural language processing. It really is very impressive. But it doesn't scream to me that, oh, you're going to have to use this. Whereas like probably the GPT-3 model, there are so many parameters in that model that I think to train it locally, even on something crazy like that, is just not even remotely possible. So I think that's the difference. We'll find out. And I totally plan in this series to include using a pre-trained model and then fine-tuning it to Python code. It's just my suspicion is there's so many little differences between regular spoken language and Python code that if we could train it from scratch, we might as well. So that's what I'm going to do. So feel free to share your opinion below, but we'll see if it works. And then, like I said, I will definitely use a much larger, the full-size data set moving forward. So to train, I'm going to just continue referencing all the things I showed you in the previous video. So the first order of business, I think what I'm going to do, we'll copy tokenizer. I'm going to make it a new file. I'm going to call it train.py. That's fine. I was tempted to get rid of like this, essentially. But I think I'll leave. I mean, it might as well just be all one file for now. I don't really think there's a problem with that. So I'm going to leave that. So we have our tokenizer. The tokenizer itself is already the GPT-2 tokenizer. So we're all set there. Essentially, all we have to add is we have to kind of like define our model. We have to define our data set. And then with Hugging Face, you need to define your like data collator. I might be mispronouncing that, but anyway, it's a thing that like batches your data set for the model to train on. So those are like the big things that are, at least off the top of my head, that we need to do. So let us go ahead and do that. Now I've already lost the, yes, there we are. This. So yeah, so we will like essentially pick up, where are we in this tutorial, basically? Here, the config. Now, we are going to use a different config. We're using the GPT-2 config. So that is, let's see if I can find this. Where is the there we go. Okay, so we'll go ahead and set, once we have our tokenizer done, I think that's the next thing that we'll do. We'll just kind of follow that tutorial. So config, and in our case, we've already actually imported it, this GPT-2 config. So GPT-2 config, and a lot of the settings are, let's see what they did. What were the settings that they did in their config? Vocab size. So I want to say so for the BERT model, it does have a different vocab size. We're going to we're just going to define our own, and we're just going to use all the defaults. We could, I don't know if we can get away, if we can change this. Because right now, our maximum context anyway, like we could try to change the context. We could also change layers. I think I'm just going to leave everything alone. The only thing we're going to define here is we've got the vocab size, and then so let's just start. So we'll say vocab size will be equal to tokenizer dot vocab size. And again, we're doing this because we're training it from scratch. We have our own unique tokenizer and all that. You could just use the pre-trained GPT-2 with the GPT-2 pre-trained tokenizer, and you can get that from Hugging Face. It's actually really simple to use their pre-trained models. Like if you saw the chatbot video, we used Dilo GPT, which if you saw that, you saw it's so easy. so I'm excited for that reason. I will test the pre-trained, but for now, we're going to do our own. So we're going to set our vocab size, and then we also want to notify it of the BOS token and the EOS token, so beginning of sentence, end of sentence. And that is tokenizer, and I think it's just .BOS token, it's ID. And then this one equals tokenizer dot EOS token underscore ID. So that is the config for our model. Now, once we have that, we can define our actual model, and that is model equals this GPT-2 LM, which stands for language model, head model, and then now we're ready to actually do the dataset thing. So that was kind of my only sore spot with Hugging Face going through these tutorials. The original tutorial builds their own dataset here, which I presume would still work. This version locks you into TorchUtil's dataset, but if you're using TensorFlow, I'm assuming you could use TensorFlow's dataset stuff. So if you knew either one of those really well, maybe you could continue using that. Then here in the updated notebook, they use, where are you? This. From Transformers import line-by-line dataset. The problem with this is it loads everything at once into memory, which wouldn't be a problem if you have a ton of memory, but it not only does it load everything into memory, it multiplies by 20. It's an absurd multiple. So or maybe even, let's see, I would say it multiplies it by 40. So on this machine here, I have 512 gigabytes of memory, and the 75 gig dataset does not fit. The one that I tested was 8 gigs. 8 gigs does fit, and it uses something like 350 gigs of memory. So that is absurd. So it's not efficient. It's not very good. Now, there is a better method, and the new kind of standard method is to use this datasets library. And so that is what we're going to use. But even that is not very well documented, at least in my opinion. I did have to enlist the help of Daniel to help me figure out how the heck do I make this work. So to do that, we'll do from datasets. We are going to import load underscore dataset. And again, to get this, pip3 install datasets like that. So we'll come down here and now we'll specify our dataset. Then we specify the collator, the trainer, and then we train. So let's do that. So we've got our model. Oh, we need to instantiate that model. Hello, there we go. So we have our model. Now for this, we'll just start. We'll say data equals load dataset. And then in here, this takes basically what kind of data is it? It's a text data set. And then the data files equals paths. And that paths was defined up here in a previous, I think we did it in the tokenizer. So this, I believe, is kind of our like generator. So this will load our data set in like a lazy loading type fashion. But then we still have to tokenize it to be fed into our model. And we have to define how will we tokenize that. And the way that you apply your tokenizer is like with this dot set, as I understand it, dot set transform. I think I've said it already in this series, but again, I am not an expert on any of this. Like this is me tinkering. This is my understanding of how it's done. So yeah. Okay. So to do that, basically you're going to say data, data, let's say data, just so it's the same as in my notes, I said data set equals that, and then data set, essentially what you want to do is do set underscore transform. And in this case, we'd like to encode that with our tokenizer. Now to do that, we need to define an encode, and encode is going to take in lines of information, and it needs to tokenize those lines. Now, this part was the hard part. I could not figure out, like, okay, well, what is these like lines object? Like, what are lines coming from load data set? And then I don't think it was documented very well anywhere. I wish it was better documented. So anyway, this is from the help of Daniel. Essentially, what we're going to do is return, and then we use our tokenizer. And we use that on lines, and then it's lines text. And like I said, I guess this produces via generator a sort of dictionary type object. Just guessing. Add, I'm just going to copy this actually. And then I want to make a fix. So paste. So add special tokens. Yes. Truncation. We would like to truncate it, but the max length, not 128, we'll make it 512. And then probably later, we'll change this to be 1024 because GPT-2's default context length is 1024. We're going to use 512 for now. So I'm just trying to see if this works. So set transform encode. Okay, so that's done. And then finally, after that, we say the dataset equals dataset train. So, okay, so now that we've got that, we're ready to do the data collator, and we don't have that yet. So let's go ahead and import that. That's from, actually, we'll just do it right here. Data collator. You're gonna run over my face. I think I'll just put it, well, we can do this, yeah. Data collator. What is it? Data collator for language modeling. Okay, good enough. I kind of want to put it over here. There we go. So now that we have that, we will copy that. We're going to come down here and we're going to say data underscore collator equals that very, very long name. Like, why do they say for language? Like, everywhere else they use LM. This should just be like DC for LM or data call. Yeah. Anyway, you could make that name shorter. Anyway, so data collator, and then here we specify our tokenizer equals our tokenizer. MLM, this stands for masked language model, and in this case it is. And then here MLM probability. This is actually the default. This is just what's the probability of assigning a masked token. So with the BERT model, the mask, can be just kind of anywhere randomly, and then the model is trained to like fill in the mask, and then it uses tokens before and after that mask to fill it in. Whereas a GPT model will only use tokens that precede the mask. So with that in mind, I don't really know how MLM probability is applied. So does that mean at each token along a sequence, it has a 15% chance of being masked? If so, then it will only fill it using the previous, tokens, and that might be very, very, very few tokens. So I don't really know. If someone knows, let me know, because maybe for a GPT-2 model, you might want something more like that. Because in theory, we were going to have like 500 tokens. Not like that. I'm sorry. Give it more like a 1% chance or something like that. Anyway, I'm going to keep it at the default. Again, just trying to see if it works. But yeah, something to think about. So data collator. So we'll just keep all the defaults on that. And then, dude, I think we are ready. Let's import our final two imports. So we're going to say from transformers, we are going to import trainer and training arguments. We'll come down here, and I think we're using mostly the same ones as the tutorial used. Let's find those. Yeah, essentially this. I'll copy and paste these, and then we'll make some changes. And then before I forget, I'm just going to say it is trainer.train. So we'll just train the model. And do they save it? I can't remember if they show how to save. I think it's like trainer.save or something. Yeah. So we'll do this before we forget that too. Cool. Okay. So we'll make some changes now. So first of all, our output directory will be gpyt. True per GPU. This actually has changed. It is this. Per GPU train batch size becomes per device train batch size. If you run it, the other one will work. It'll just tell you that it's been updated. So it's this now. I'm going to set this to 10 just so we test it locally to see if it works. The GPT-2 model is quite a large model. So if it doesn't work on your machine, you'll want to probably edit the config and set way less layers, a different size, and so on. So if you have a small baby GPU, keep that in mind. It might be tough. And then while we're thinking about it, when we save the model, let's save it to gpy, gpyt. And then before I forget, let's go ahead and just make that directory. I can't remember if it'll make it for us. gpyt. So boop. Cool. Save steps. We're going to save every 100. This will essentially just save like a checkpoint file for us. So 100. Again, this is a very large model. The model that they use in their tutorial is like a much smaller model. I think that's why they're allowing 10,000 steps. Prediction loss. And then I'm not really sure. Remove unused. I have this in my notes and I'm not sure why. I'm going to keep it in there. So I just added that one. Number of training epochs at 1. Save total limit 2. This is how many checkpoints to save at a time. That way just each checkpoint's going to be like 500 megabytes. So you wouldn't want to save a ton of them. Maybe we're ready. I'm sure I'm forgetting something. We'll just save it, and we'll find out what we're forgetting. Once we see this works, I'm going to move things over to the DGX station and then see how long will it actually take. But before then, I just want to eradicate errors. Do we pass? I guess we have to pass the config in there. Did I really forget that? Yep. Okay. Yeah, I like to find config and never used it. That's okay. A fancier editor would have told us. Okay, I don't recognize this one at all. Data files. Let's see. Data files. Where is... It's just data underscore files. Yeah. So this needs a data underscore files, and then it's equal to paths. So data underscore files. I've lost my, there it is. Take 97. Ooh. Maybe? Oh, we are stepping. I think I'm going to break that. 46 minutes and watch NVIDIA SMI. What are we doing? 12 gigs? Okay. Whew, that was really laggy. Hopefully that didn't murder the recording. But anyway, okay. So that did train. It was 12 gigs for a batch size of 10. So what would that be? 12. We could probably times 5. So maybe we'll say a batch size of 50 or 60 for the DGX station. We'll find out. So this file is ready. So actually what I'm going to do is I'm going to move the files to there, and then we'll shell in, and then we'll go from there. Okay, I think I've moved everything over there. So SSH, DGX, A100. Oh my God. Nobody look at my password, please. Thank you. Alrighty. Let's go CD RAID, and then what was the directory? G Pi T video. Cool. All right, so now Python 3 train.py. Oh, I didn't change the batch size. Hold up. Wait. Stop. Nano train.py. Can we just... Oh, we got to make a couple of changes here, actually. Dang it. Okay, I made a couple of quick edits there. The one change that I made is import OS, and then here we're just setting the available CUDA devices. The reason for that I will show in a moment, and then the only other thing I did was set the batch size to 60 for now. We'll see if that works. That might actually blow memory. We'll find out. So that's 60 per GPU. So we will exit. So effectively, what, 60 times 4, 240? The batch size will be 240. If we pop into, in fact, I think I'll just open another terminal. SSH DGX A100. Oh my gosh. And if I go watch NVIDIA SMI, what we'll see here is why I set the GPUs the way I did. So not all GPUs are created equal. This GPU is just the display GPU. So the A100s, we don't connect any monitors or anything to them. But to display a monitor, it has this little display card, and it only has 2 gigs of memory, whereas the A100s have 81 gigs of memory. So that is why we're here. So this is GPU 0, 1, 2. We want to ignore GPU 3, because if we try to stick a batch size of 60 on GPU 3, it will not end well. So we want to use 0, 1, 2, and 4 for our GPUs. So let me set this over here for now, and let's go ahead and run train.py. Hopefully we didn't kill anything by breaking it like we did. Why can't I get this to... There we go. I just wanted to show that while we start stepping. Kind of want to show both somehow. There we go. And we're off. And we're maxing. So the main GPU, this is kind of like your, it's serving everything. So, it might actually run out of memory. Oof. Oh, we're hitting 78. Man, there's some serious fluctuations in memory here. Usually the main GPU has more memory usage. What? I'm sorry. What was it locally? I can't remember what my local time was. I'm sorry. That's so insane. This is going to take 3 minutes. I think, oh man. I think locally it was going to take like 2 hours. Oh God. Okay. Yeah. That's insane. Okay. I guess we'll come back in a couple minutes. I guess. So I think you normally get like metrics after every 500 steps or something like that. So I don't even think we'll have got, like, we're just not going to get any metrics. That whole thing trained in 4 minutes. That's just absurd. Oh man. Okay. So now what I think I'm going to do is I'm going to actually move the model. How do I want to do this? I think I'm going to move the model back locally. I mean, I don't need, mostly you just want the DGX station for training. So, so I'm going to actually copy the model back over. So the model, just for the record, if we cd into gpy-t, we'll actually see multiple things here. We'll see so here, let's see, config.json. Let's cd into this checkpoint. I forget which, checkpoint, let's say 200. If it's all three. Yeah, it's all three of those things it looks like. So we'll shoot you back. So really these three files define the model. So this was the model at the end of training. So we'll just copy the whole thing over, but you could either load in via checkpoint by, like, when we go to load the model, you'll see it in a second, but we could say checkpoint 200, checkpoint 300, or we could load in and say, hey, the model is located at this gpy-t directory, and any of those would work, just for the record. Okay, so I've got the things copied over. We check the gpy-t directory. Again, we'll probably use this one since this will be like the latest and greatest. Again, we'll probably see a bunch of gobbledygook here, and we'll probably need to train for multiple epochs, but we'll go ahead and code it, and then I'll train it for multiple epochs probably, and then come back and show you the results. Train.py, let's say use model, I guess we'll call this use model .py, and we'll leave everything here. There's really no problem, I don't think, leaving all of this. The thing that will change is, let's see, GPT-2 head model, LM head model. Yeah, basically this, delete all this. And rather than the config stuff, we're going to say it's actually a GPT-2 LM head model dot from underscore pre-trained. How did it know? Did we do that? Oh, okay. So it's the same kind of call from the tokenizer. So how did you know to autocomplete that? And then we'll specify where is that. So it's gpy-t. And then because we are using Torch, we need to 2.2 CUDA, so we get nice fast results. And now we have our model. Now to use the model, we essentially are going to have input. How do I want to do this? Yeah. So we will do while true. We'll just say input equal. Can't do that. Imp equals input. That, and then we will go ahead and tokenize the input. So we'll just say input underscore IDs equals, and this will be tokenizer dot encode, and we are going to encode whatever we did imp on, and then return underscore tensors will be PT for PyTorch. And then again, we want this to go to our CUDA device, which I don't really actually think, I'm not sure it would actually matter, but I think we want to lowercase this. Tokenizer text, let's see, this goes in. For now, I'll add this, but I don't think we're going to test anything. It won't come to this, I don't think, in this video, but input equals imp.replace. And we will replace, shoot, how do I want to? I'm going to leave this alone for now. We're not going to mess with that. I was going to handle for the new line characters stuff, but I think we'll leave it. Input IDs, to CUDA. What else do we need? So now we're going to specify the beam output from this model, beam output, and that will be equal to a model.generate. And here we are going to generate from the input IDs. We are going to say the max, and in fact, let's put this down here too. Max length, we'll set that to 512. We'll say the num beams is 10. The temperature we will set to, I think the default is 0.7. So number of beams is like, basically it's gonna reach a token, a mask token. And what model generate's going to do is it's going to generate a string of text until it reaches an end of sentence token, essentially, or hits the max length. But each token along the way has, let's say, a score or something of which one do we choose. But there might be an array of possible tokens, and then each token that you pick, that changes the next token's possibilities. So beams and temperature can be used to give you a variety of outputs to possibly choose from at the very end. At least from what I've seen, it doesn't seem to be making any difference for me here. This is something I plan to play with, maybe from a pre-trained model, to see if that makes a huge impact. But so far, I haven't noticed that it does. And again, if I'm saying something stupid, feel free to correct me. No repeat n-gram size. I think this is literally the repetition of outputs. So and it doesn't seem to include special tokens. Again, I'm knowing less and less as we go through these parameters. But in this case, I'm going to set it to 5. And again, all this is going to do is it's going to stop like the same exact token from being outputted, I think, 5 times. But again, I could be totally wrong there. That one, we can tinker with that, and I'll show you how the output differs, because that one does seem to make a difference. And then here, num return sequences. I'm going to set this to 1 because, again, I have not noticed that num beams and temperature. So temperature is like a degree of like uniqueness or randomness. And again, modifying this, it's from 0 to 1. Modifying this, I have not noticed from the trained from scratch models that I've played with. I haven't noticed that it makes any difference. So then finally, right now we just have the 1 sequence, so there's really no big deal. But for beam in, beam output, we are going to say out equals tokenizer.decode that beam out, and then f out will be equal to out dot, and in this case we are going to go ahead and replace any new line with an actual new line character. So when we display it on the screen, let's see, we did bring that in, so we'll go ahead and print green string found. I think that's going to be a string, but we'll just make sure. And cool. Okay. Let's see if that works. We are no longer training. Test. Loading the model. Cool. I think we're good. Let's go ahead. Again, this is probably going to be disgusting. I don't think it's going to work. We're going to have to make many more epochs on that tiny data set if it will ever work. But let's just see. Probably should just have defined some sort of input, but whatever. Print. Hello. Dude, you're really slow. Okay, so that's actually better than what I was expecting, in all honesty, because this is such a young model. I'm kind of surprised that it looks this good. Wow. I kind of want to train for 10 more epochs or something and then come back and show you guys. I really didn't expect it to look like this even at all. So obviously this is unacceptable Python code, but it was, again, unacceptable size of data, and even then it was an unacceptable training time of like 4 minutes. Yes, it was on the behemoth machine, but still not enough. Okay, yeah, I guess I'll do you guys a solid. I will train maybe for 10 epochs. I don't know if I want to wait 40 minutes on a model that I know is not going to be very good. Maybe I'll do like 5 epochs or something. I don't know. Anyway, I'll make it. I'll come back and I'll show you what we get with a slightly better model than this. All right, and we're back. So I did 7 epochs. That took 26 minutes and 44 seconds on our very, very pathetically small data set. But I just wanted to do it because I was pretty impressed with these results on 1 epoch. So I just wanted to see it real quick. This is the tensor board. Not really too much to write home about. The epochs, of course, went up. Learning rate does decay automatically with these models. And we can see that loss, let's set this down, loss did indeed decline. So, okay, let's check the results now. So I have actually already moved over the files, and if I recall right, we don't actually need to change anything because we load the GPyT model from pre-trained. I copied that model over. So I actually think we could just, break out of this. Let's see, Control C to break. I didn't realize that was still running. Run that again. Hopefully we'll load the new model. And let's go ahead and print again. Hello. I don't know. We'll just do that. Let's see what happens. I just want to see it. Come on. Let's go up to the top here. Print hello. So at least you can see we did not close off our quotes or the parentheses. It went ahead and did that for us. It also went ahead and started populating with some code. My guess is our data set is so small that this is probably identical to something in our data set, at least to some extent. So that's interesting. Let's check a couple of autocompletes. So what if we say, well, first let's see what happens when we just import. I'm just curious, like what do we grab when we import? And then also maybe like import NumPy and then see does it suggest initially as NP. So import, it does sys, it does the system check, and this is actually, isn't that pretty identical to what we had up here? Mirror. Oh, not, it is a little different. Interesting. Let's go ahead and import NumPy. Let's just see if it finishes as NP, let's say. And the other thing to note is it is indeed doing like new lines and white space to some extent correctly. So like if colon and it does the white space, it did the new line. We are replacing out the new line, but anyway, let's see if it did NP. It did. Oh, I can't. This is such a baby model on the dumbest data set. And that actually works. Dang. I mean, this is kind of silly, like passing self to a regular function. Like, it's not the greatest, but as far as a line complete on a typical import, not bad. Import torch. Let's see what happens. I'm really surprised. I really am. This is like nothing. Import torch sys. I mean, if MyPy check warning, I don't know what the heck all this is, but else define it itself. I mean, it knows some stuff. I mean, it's pretty cute. Not gonna lie. Wow. I'm impressed. Wow, it's gonna be hard to top that, but okay. What we're gonna do, or what I'm gonna do, is I'm gonna train the much larger data set now. See what results from that, and then possibly after that increase the length, the context length. So like right now, the default is 1024, but the longest sequence we're passing could possibly be 512. So I think I'll maybe make a proper data set of that length. And then maybe train that one too. I don't know. Anyway, yeah, wow, those are really impressive results. I'm shocked. I really am quite surprised. I cannot believe that with a mere 70,000 samples in like 20 minutes of or 26 minutes of training it is on the A100s. That would take considerably longer on a regular machine. Like even on these RTX Titans, that would take a very long time, many hours. Man, I cannot believe that it did that. Okay. Yeah, I'm going to train a bigger model and we'll come back. If you guys have questions, comments, suggestions, whatever, feel free to leave those below. Otherwise, I'll see you guys in another video.